Kibas Online Academy. Today you have session 2. Kipindi kilichopita tuliangalia part ya kwanza ambayo ilikuwa time value of money. Leo tunakwenda part ya pili ambayo tutadili na statistics for finance and investment. Tutafanya summary then tutafanya solving katika vipengele vifuatavyo. Kwanza tutaanza na random variable and probability distribution function, lakini tutafanya estimation of parameters, then tutafanya hypothesis, then itakuwa simple linear regression model, then multiple linear regression model. For starting with the random variable and the probability distribution function. Random variable and the probability distribution function. This probability distribution function is divided by two types, ambayo ya kwanza ni decrease probability distribution, ambayo ndani yake ina probability mass function PMF, ambayo ina properties zifuatazo. Tunasema function f(x) is greater than or equal to 0 for each x is equal to x. Property ya pili ni 0 is less than or equal to function here, meaning this is probability ya x, and probability ya x is less than or equal to 1. And the property ya tatu tunasema ni summation. Ukichukua summation za probability zote zinatakiwa ziwe sawa sawa na moja. Lakini type ya pili tuna continuous probability, ambayo ndani yake kuna probability density function, ambapo property zake tunasema ni 0 is less than or equal to function ya f(x), and function ya f(x) is less than or equal to 1. Ukichukua integration ya function ya f(x) dx inatakiwa iwe ni sawa na 1. And ya mwisho a, ukichukua integrated ya f(x) dA inatakiwa iwe ni integrated function ya f(x) dx. Lakini hapa tunaangalia kutafuta namna ya kutafuta expected value of decreased probability distribution. Expected value denoted by EX bracket x. So formulas, expected value inakuwa ni summation ya x f of x. Property of summation notation, kwamba tunasema kama k is constant, when you have constant, so summation ya constant number is equal to n times constant number, and the summation ya constant number with variable is equal to constant number inakuja nje, then tutasum zile variables. Lakini 3, if both a and b are constant, kama tunavyo a and b are constant like this, itakuwa tunatoa na because a haina variable plus b ita substitute out, then summation ya xi. Lakini pia we have this property of expected value. Tunasema hizi ndo za msingi kuzingatia. Property za expected value tunasema kama k is constant. Kwa hiyo tukiwa tuna expected value ambayo ni constant, itabaki ni ile constant. Sum of two variable, kama tunajumlisha expected value ya number ya variable mbili a and b, itakuwa sawa na expected value ya a plus expected value ya b. Lakini 3, we have product of two variable. When you have product of two variable, expected value x y, then itakuwa ni expected value ya x times expected value ya y. Lakini 4, we have this product of constant and variable. Product of constant and variable like this, we have expected value ya kx, then itakuwa ni k that is substitute out, then itakuwa times by expected value ya x if k is constant. 5, if a and b are constant like this, expected ax plus b, a and b are constant, then we get expected ax plus eb. But this we can go further. Expected value, as you remember, product will substitute this out, then we back in expected value x. Variance and standard deviation. Namna kutafuta variance and standard deviation. Variance ya x itakuwa ni summation ya x square function ya f(x) minus summation ya x times f of x ikiwa squared. Standard deviation we say it is under root of variance. Covariance we say the expected value ya xy minus mu x mu y. Correlation is equal to covariance ya xy over standard deviation ya x times the standard deviation ya y. Hii namna kutafuta correlation. Then we have a linear combination of random variable. Expected value yake inakuwa iko hivi. Linear combination of then we have this linear equation. Z is equal to ax plus by. Deduce expected ya z and variance ya z. So tutafuta expected ya z, itachukua itakuwa ni a, tutasubstitute out a, then itakuwa ni expected ya x plus tutasubstitute b, itakuwa expected ya y. Here is y not x, sorry. Then variance ya z itakuwa ni a square, variance ya x b plus b square, variance ya y plus 2ab, because we have two variable ab, this is weight ab or probability, covariance ya x and y. Application in portfolio mathematics. So how we apply in portfolio. Then tutaangalia kwenye portfolio the expected return of portfolio, the expected variance of the portfolio, the expected standard deviation, the expected variance of the portfolio if the two securities are independent. So then we have this expected return on portfolio, expected return ya portfolio. So expected return ya portfolio inakuwa niko hivi. Weight when we have two variable. When you have two variable, expected return ya portfolio itakuwa ni weight ya variable ya kwanza times expected return ya variable ya kwanza ambayo ni x plus weight ya y, expected return ya y, hii variable ya 2. Where RP ni return on portfolio, W is weight. Note weight of portfolio does not exceed 100 or 1. The expected variance of the portfolio. So we have this one, two variable in the variance. Two variable variance will return portfolio of two variables. We get weight ya variable ya kwanza ambayo ni x, tunai square, then tunazidisha na variance ya x plus weight ya y times variance ya y plus 2 weight ya x, weight ya y, covariance ya x y. Namna utafuta covariance inakuwa ni this is what correlation times standard deviation times standard deviation times standard deviation ya x times standard deviation ya y. When we have three variable x, y and z, then variance ya return ya portfolio itakuwa ni weight ya x square, variance ya x plus weight ya y square, variance ya y ambayo ni variable ya pili. Then we add variable ya tatu ambayo ni z, itakuwa ni weight ya z, weight yake square, variance ya z plus 2wx wy, covariance ya x y. Hiyo ya kwanza, combination ya x and y. Then we have combination ya x and z, so we will add plus 2 weight ya x, weight ya z, covariance ya x and z. Then we have combination ya y and z, so we'll add 2 x weight ya y times weight ya z times covariance ya y and z. Standard deviation as usual is under root of variance. If two securities are independent, then covariance is 0. The covariance is 0. Standard normal distribution table, we have this. This standard normal distribution table show a cumulative probability association with a particular z-score. So like this. Graph yake inakuwa iko hivi, this is the middle part. Standard normal distribution. Z is equal to x minus mu over standard deviation, where z has a zero mean and an unit variance like this. Z is normal distribution, bracket 0, and this is z and this is mu. Sampling distribution like this. In sampling distribution we use x bar, that's mean. how to find mean is equal to summation ya variable over number of variables. Let's say summation ya x over n. Then expected means is equal to mu, we denote by, so here expected x bar we denote by mu, like this. So variance x bar is we denote by standard variance over n. Standard error, here we find the standard error is equal to standard deviation over under n. Z score is equal to x bar mean minus mu over standard error, like this, x bar minus mu over standard error. So relationship between population and sampling is like this. In sampling, when we find what denotation zake zinakuwa in term of x bar, huku inakuwa ni expected here. In population inakuwa ni expected ya x. In sampling we denote by x bar. Remember here expected return summation yake tunatafuta inakuwa summation ya variable times if function ya x function ya x, function ya x, lakini here in variance we are tunaitafuta coordinate by variance ya x, while huku inakuwa denoted by s, that is variance. So standard deviation as used, standard deviation ya x, standard deviation ya x, like them the same. Yeah. So we have this problem solving. We have question this. I refer this from question. I refer this from group assignment 1, question number 2. Also, I take some examples from class. A anasema a return label x to a certain investment $1,000 has the following probability distribution. Tumepewa distribution hii hapa, tuna x then tuna probability za x na -10, -4, 0, 20, 25. Then we have 0.10, 0.15, 0.25, 0.30, 0.2. Find the following probability. To find the probability kwamba x ni ndogo kuliko 0. Then ya pili to find the probability kwamba x ni kubwa kuliko -4. Then baada ya hapo to determine the expected value and the standard deviation of the return, like this. Then here B, suppose that a net present value and PV depend on x above. Sawa, and PV na depend katika Roman A. Compute an expected value and the variance of PV given that tumepewa linear equation, kipengele kingine cha linear, and PV is equal to -10 plus x over 1.4. 3, meaning kipengele cha C. 3 equally weighted and independent return Ri for I is equal to 1, 2, 3 constitute a portfolio return RP. Suppose that the following information is available. Expected ya R1 is equal to expected ya R2 ambayo is equal to 10, expected ya R3 is equal to 7, variance ya R1 is equal to 6, variance ya R2 is equal to 12, and variance ya R3 is equal to 9. Compute the expected return and standard deviation for the entire portfolio. D, suppose that mu is equal to 10 and standard deviation is equal to 15. Find probability that the x is less than 16. So tafute probability kwamba x ni ndogo kuliko 16. Then suppose that mu is equal to 200, standard deviation of 9 and n sample n 71. Find standard error, then find P, probability that x bar is greater than 170. Solution. A Roman 1 we have tunatafuta probability kwamba x ni ndogo kuliko 0 from the data tuliopewa here. When I turn back here